Learn from every question. Learn from every question. Right. Okay. Question number 5. 4 discussed 5. 4 discussed 5. A disk of mass simple limb and radius simple r. A disk of mass simple limb and radius simple r rotating at constant angular velocity omega. What should be the angular velocity omega 1? What should be the angular velocity omega 1 if the system, when the second disk of mass m by 2 and radius simple r is placed on the initial disk gently, right? Okay. Right. Okay. So look here. Now this is about conservation of angular momentum stories. Conservation of angular momentum story. Right. Okay. Okay. Now what they have mentioned, question number 5. Disk of mass simple limb, radius simple r. So we have done plenty of similar questions in our past discussions. So therefore, you should be able to get the answer. If I draw a disk of mass simple limb, radius simple r. Mass simple limb, radius simple r. Right? Rotating at a constant angular velocity omega. Angular velocity of the disk is omega. Right? Okay. Just before. What should be the angular velocity omega 1 of the system when the second disk of mass m by 2 and radius simple r is placed on initial disk gently? Now, why do they have given we are placing the second disk on top of first disk gently? Gently means, remember, during this process, they are essentially resultant torque acting on the system. During this process, they are essentially resultant torque acting on the system. That's why they mention gently. When you place gently, there won't be any forces acting on the system. As a result, there won't be any resultant torque acting on the system. Therefore, you can tell that when you consider before and after, resultant torque acting on the system is zero. That means angular momentum, capital L equals I omega. That story. Angular momentum is conserved before and after. Angular momentum of the system is constant. Before and after, angular momentum system is constant. That story. Right. So then, so we are placing another disk on top of this one. Black color disk is at the bottom. Black color disk mass is, as I explained, simple limb and radius simple r. You kept another disk on top of black color disk, that is red color disk. Its mass is m over 2, but radius is same as simple r. Mass m over 2, radius same as simple r. Radius same as simple r. Axis of rotation is the axis of rotation. They have given once you place the second disk on top of the first disk, angular velocity of the entire system is omega 1. Omega 1. Right. What we want to find in this question? Before and after. In this question, we want to find, they're asking omega 1 in terms of omega. Right. So then I can draw the red color disk in this scenario also. Before scenario, red color disk was at rest. I can draw the red color disk. When I draw the red color disk, remember, actually red color disk was at rest before. So once you place the red color disk on top of the black color disk only, both of them start rotating under constant angular velocity omega 1. Right. So remember, the summary is very simple. You learned this thing already. when the resultant torque acting on the system is zero. When the resultant torque acting on the system is zero, we learned that angular momentum is a constant. We learned angular momentum is a constant. This is a story we learned. Angular momentum before and after constant means before angular momentum must be equal to after angular momentum. Before angular momentum is, let's say, L1 must be equal to after angular momentum L2. This means what? L1 must be equal to L2. And we learned some equations for angular momentum. There are three equations we learned. One is angular momentum equals I omega, moment of inertia into the angular velocity. The very popular equation for angular momentum is, we all know that L equals I omega. L equals I omega equation is very popular. So then we can say that before total angular momentum must be equal to after total angular momentum. That is the conservation of angular momentum depicts. Now we can go to story. I have discussed the stories in our past discussions. Only 6 MCQs pending in past paper rotational motion. So we have done closely 50 MCQs in past papers. We have covered everything. Only 6 MCQs pending in past paper, rotational motion story, everything explained. Everything explained. So what we can do, we can apply conservation of angular momentum. Conservation of angular momentum. That means what? Let's say now I'm applying conservation of angular momentum in the anti-clockwise direction, right? Then what is the total angular momentum of the system before? System means black color disk plus red color disk both. That is your system. Total angular momentum before. Moment of inertia now. Since this red color disk is at rest, angular velocity is zero. Therefore, remember, red color disk does not have any angular momentum. Since black color disk is rotating, black color disk has an angular momentum. What is the angular momentum of black color disk? Moment of inertia of the disk is how much? Let's say I1. Moment of inertia of the black color disk is I1. We learned in rotational motion, what is the equation to find the moment of inertia of a disk? The equation to find the moment of inertia of a disk is, we all know that it's a disk of mass simple element radius simple r. Moment of inertia of a disk is, remember, half mr square. If it's a disk of mass simple element radius simple r, moment of inertia of a disk is half mr square. Important theories you must remember. Then only you can solve this question. If not, you can't solve. If not, you can't solve. Right. Then what can I do? Before angular momentum is, we all know that half mr squared. Sorry, before moment of inertia of the disk is half mr squared. Right. If I apply I1 omega 1 equals I2 omega 2. I1 omega 1 equals I2 omega 2 story. Before angular momentum going to be. Before angular momentum is moment of inertia of the black color disk before half mass simple m radius simple r. Have simple m simple r squared. Angular velocity of the black color disk before omega must be equal to total moment of inertia of the system after moment of inertia of black color disk plus moment of inertia of red color disk y. Both of them are rotating. Therefore, we want to consider both of their moment of inertias. What is the moment of inertia of black color disk? As we already wrote, half m r squared. Half m r squared plus what is the moment of inertia of red color disk? Red color disk moment of inertia is, we all know that half mass of the red color disk is m over 2. The radius same as r squared into the angular velocity of the system is omega 1. Target is finding omega 1 in terms of omega. Simplification. Simplification here, what we can do here we can cancel out, I can take half m r squared out from this bracket. This is the theory. Then here half simple m simple r squared into omega must be equal to, if I take half m r squared out, half m r squared out, 1 plus half m r squared out means half into omega 1 into omega 1. We can cancel out half m r squared completely. Then what's remaining? 1 plus 1 over 2 means 3 over 2. Here it's 3 over 2. Sum of the subject omega 1. Omega 1 going to be, to the simplification, I didn't get the final answer. Omega 1 going to be here 3 over 2, 2 over 3 omega. 2 over 3 omega. Omega 1 going to be 2 over 3 omega. Sorry. Then question number 5 answer is, question number 5 answer going to be 2 over 3 omega. 2 over 3 omega means what is the answer? 2 over 3 omega means answer is 5. Answer is 5. Answer is 5. Question number 5, answer is 5. Done. Right. There are some questions, they are easy questions are there. Right. Right. Raise your hands. Okay, question number 6. I explained this story in oscillation and waves when I was explaining about characteristics of waves, especially refraction of water waves. I said that when you consider two water regions, one region is a shallow region, other one is a deep region. In that case, I taught you that even though that is a water medium, when the depth changes, I told you both the regions act as two different mediums. One is rarer, one is denser. Right? And we all know that if you forget what you do, write down important things. When I explain, if you feel you forgot something in your short notebook, in your what review book, just write down all the important points I'm explaining. So then we understand that even though same water, based on the depth of the water, we can divide them into shallow region and deep region. So remember, shallow region and deep region of water behaves as two different mediums. Normally we consider water having a deeper region. Normally we consider water having deeper region, we call it as a rare medium. Water having shallow region, we call it as dense medium. Why? Because we all know that if you understood the stories, we all know that velocity of water waves larger in deep region. Velocity of water waves smaller in shallow region. Right? Larger velocity, if wave is having a larger velocity means that is a rare medium. If the wave is having a smaller velocity means that is a dense medium. That story explained. Tell me the right answer. Question number 6, right answer. Raise your hands. How many we see? A water wave that occurs on a water surface moves from shallow area to a deeper area. Raise your hands. The right answer is option 1 answer. The wavelength decreases and the frequency increases. In that question, right answer is first one answer. Right answer is second one answer. The right answer must be second one answer. Second one. The frequency decreases and the wave velocity decreases. We know that when water waves propagating from shallow region to deeper region, frequency doesn't change. During a refraction, we learned that frequency remains constant. During a refraction, when water is refracting from shallow region to deeper region, what's happening? Velocity of the water wave changes. As a result, wavelength of the water changes according to V equals F lambda equation. Question number 6, we all know the story. Recently, we learned these ideas. You can apply V equals F lambda equation for any wave. It can be electromagnetic wave, sound wave, water wave. So we learned that during a refraction, frequency remains constant. Frequency remains constant. When velocity of the wave increases, we learned that wavelength of the wave also increases. That was the right answer. The frequency decreases is wrong. Frequency remains constant. Fourth option, the wavelength increases while the frequency remains constant. Now, shallow region to deep region. What's happening? Shallow to deeper, what will happen with the velocity? Raise your hands, how many we say, sir, when water waves entering from shallow region to deep region, velocity of the water waves decreases. So when water is entering from shallow region to deeper region, water is entering from shallow region to deeper region, velocity of the water waves decreases. So velocity of the water waves should be increased as it entering from shallow to deep. Obviously increasing. Velocity increases means you want to understand shallow to deeper. Remember, shallow to deeper. Shallow to deeper. A velocity of the water waves increases. When velocity increases, you want to understand frequency constant, wavelength increases. You also learned the equation, V equals GH equation. Velocity of water waves equals gravitational acceleration into the depth of the water. This story also we learned. This story also we learned. This study we learned. So therefore, I think answer is going to be fifth one is the answer. As per my understanding, wavelength increases, yes, while the frequency remains constant. Question number 6 answer is 5. Question number 6 answer is 5. The next story. Next story. Seventh one. Seventh one, nice story is there. Nice story, seventh one. Seventh one is a nice story. So you can easily fall into the trap. Question number 7. You can easily fall into a trap. Question number 7. But in the theory classes, I explained everything properly. You should be able to get the right answer. Question number 7. Right. What they are asking, the question. So question number 6, fourth and fifth answers are same. Question number 6, fourth and fifth answers are same. Wavelength increases while frequency remains constant. Oh, good. Right. Answer is 4 and 5. Answer is 4 and 5. Next story. Next story. Next story. An object is in equilibrium under the influence of three forces. An object is in equilibrium under the influence of three forces, always acting in the same plane. There are three coplanar forces acting on an object. That object is under equilibrium. Right? Clear? Always. Now they have given 4 statements. Always. They are telling always. Always. Have given 4 statements. Statement capital A. Statement B. Statement C. Statement D. Statement A says that always algebraic sum of the moments means torques, algebraic sum of the torques about any point in the same plane is 0. That's very simple. Just consider that's an object. This story explained when an object is under equilibrium. Let's say this object is under equilibrium. Then if this object is under equilibrium, this object should satisfy 2 conditions. The first condition is resultant force must be 0. Right? If it is in equilibrium, the first condition is resultant force acting on the object must be 0. Second condition is when you consider any point on the object or any point outside the same plane, you can consider any point outside, you can consider any point in the object. When you find the resultant torque must be 0. These are the conditions, 2 conditions. If it is under equilibrium, right? Okay. Option A, they are telling that algebraic sum of the moments. Algebraic sum of the moments means algebraic sum of the torques means they are talking about resultant torque. They are talking about resultant torque. Resultant torque about any point in the plane is 0. That's correct. Statement A is correct. As per my understanding, statement A is correct. You understand story, right? Now they are talking about an object. In the question, they are telling specifically an object is in equilibrium under influence of 3 forces. An object is under equilibrium. An object is under equilibrium under influence of 3 forces. Remember, I taught you when I was explaining momentum forces, these talk stories. When you consider an object's equilibrium under 3 coplanar forces, I taught you there are 2 possible equilibrium states. There are 2 possible equilibrium states. State 1 is this object can be under equilibrium due to 3 inclined forces. If not, this object can be under equilibrium due to 3 parallel forces. Its equilibrium can be 2 states. The story explained. That's how they're asking. Learn these tricky points. The first story is, now let's say now this is under equilibrium under 3 inclined forces. This force F1, then I explained that line of action of F1 is going to be this direction. And there's another force acting on this object is F2. line of action of F2 force going in this direction. And there is another force acting on this object, that is F3. F3. So line of action of F3 force going to be this way. I told you, suppose if this object is under equilibrium due to three coplanar inclined forces, I told you that their lines of action, their line of actions must meet at the same point. It is object is under equilibrium with three coplanar inclined forces. All of their line of actions must exactly meet at a certain point. Very important point. You write down. Short note point. Short note points. Short note points. Remember, if an object is under equilibrium with three coplanar inclined forces, definitely their lines of action must meet at same point, right? So then this object under equilibrium with three coplanar forces, the other possibilities, it can under equilibrium due to three parallel forces. Same object can be under equilibrium with three parallel forces. Let's see, this force is F1 parallel, F1 force, this one is F2, and just another force acting on this object, F3. Suppose if an object is under equilibrium due to three parallel coplanar forces, is it compulsory to meet their lines of action at the same point? No. No. If the forces are inclined, definitely all three forces lines of action must meet at the same point. If the forces are parallel, lines of actions won't meet, all the lines of actions won't meet at the same point, right? If the forces are parallel, lines of actions not necessary to meet at the same point. That story I explained. The theory classes, these are some important points. Now we'll go to the story. This story is important. We'll go to the story. Story, capital B option, lines of action of three forces meet at a point. Now they are talking about, specifically they are telling there's an object under equilibrium due to three coplanar forces. That three coplanar forces can be inclined three coplanar forces. If not, the three coplanar forces can be parallel three coplanar forces. If it is inclined only, statement B is correct. If it is parallel, statement B is wrong. Statement B is wrong. So therefore, always statement B is not correct. Always statement B is not correct. Statement B is wrong. Nice story. I think you can learn something. You can revise something from these questions. That is the ultimate goal of doing a target paper class. Option C, the resultant force is zero. Obviously, if it is under equilibrium, resultant force of that object must be zero. Statement C is correct. Statement D. Statement D. Statement D. What they are telling? Statement D. They are telling the resultant of any two force is equal to the magnitude of the third force. That's correct. That's correct, right? That's correct, right? The resultant of any two force must be equal to the magnitude of other force. For example, when you consider F1 and F2, the resultant of F1 and F2, the resultant force of F1, F2 must be equal to magnitude of F3 and opposite. Let's say the resultant of F1, F2 is, for an example, I say, if you mark the resultant of F1 and F2, definitely that should be opposite to F3. That should be opposite F3. Magnitude wise, R's magnitude must be equal to F3's magnitude. If not, if you consider F1 and F3, when you consider F1 and F3, resultant of F1 and F3 must be opposite to F2. Must be opposite to F2. The story is write down. The story is you want to write down. Must be opposite to F2. The resultant of F1 and F3 must be opposite to, if it is under equilibrium, must be opposite to F2. Magnitude wise, they are equal. That's what is clear. Not only for inclined three forces, but also parallel three forces also is the logic. The resultant of F1 and F2. When you find the resultant of F1 and F3, for example. Okay, resultant of F1 and resultant of F1 and F2 must be exactly opposite to F3. Just you write down. If you consider resultant of F2 and F3 must be exactly opposite to F1. It is not properly working. I think this idea, I think you understand. If you have a doubt, please put a message. Then option D also correct. Any answer? ACD correct. ACD correct any answer? ACD correct any answer? ACD. Sir, for sixth question, fourth also correct. Yeah, I already explained. ACD any answer? ACD only fourth one is the answer. Question number 7, answer is 4. Question number 7, answer is 4. Next story. Question number 8. Question number 8. Question number 8. An ice cube floats on seawater. An ice cube floats on seawater. Density of seawater and ice cube are 1000 kilograms per meter cube and 920 kilograms per meter cube respectively. Find the percentage of volume of ice. Percentage of volume of ice which is above the surface of the seawater. I have done past paper all the hydraulic stories, right? I have done very similar questions in past discussions. Therefore, you should be able to do this question. If you properly learn the stories, you should be able to do the question. Question number 8. 8 story. Ice cube, seawater. Given data 920,000 percentage of volume of ice above seawater. Above seawater. Above seawater. Right. Seawater level and my ice cube. Is my ice cube. And you can take the cross-sectional area of this ice cube as capital A. I'm not drawing a 3D diagram. I hope you understand. I don't draw a 3D diagram. For your understanding, I mark the cross-sectional area of the ice cube. Let's take it as capital E. Cross-sectional area. Let's take it as capital E. Capital E. And seawater, density of seawater, let's say rho W. And density of ice cube, let's mark it as rho. Density of ice cube, let's mark it as rho. Density of seawater, let's mark as rho W. Let's say the volume above the volume of the ice cube above the seawater level. Seawater level above the volume of the ice cube. Let's say capital V1. Capital V1. Volume of the ice cube above the seawater level. That means this volume. This volume is, let's say, V1. Volume of the ice cube above the seawater level, that is V1. And also, let's say the total volume of the ice cube. The total volume of the ice cube, the entire volume of the ice cube. Let's mark it as capital V0 something. Entire volume is capital V0. The total volume. The total volume. Total volume I mark it as V0. V0. Total volume. Right? Okay. So then normally we know that this type of questions, we mark the forces acting on the ice cube. There are two forces. We know with the experience, we know that there are two forces acting on the ice cube. One is definitely the weight of the ice cube acting down direction. The weight is acting down direction, mg. And other one is the upthrust force. One is the weight simple mg, ice cube mass simple m, ice cube weight downward direction mg. Other forces we all know upthrust force. Upthrust force acting on the ice cube, that is capital U, mg and u. So since the ice cube is under equilibrium, what we can do, if the ice cube is under equilibrium, what we can do, we can equal upward force upthrust equals to downward force mg. Then you must be equal to mg. So when you consider equilibrium, we can tell that upthrust must be equal to the weight simple mg. And we've learned that upthrust, the equation for upthrust, u equals v rho g. Equation for upthrust, we will know that u equals v rho g. What is the meaning of each term? V means submerged volume of the object. Rho means density of the liquid where the object is submerged. Density of the liquid. G means gravitational acceleration. This story we know. And also we all know that when you consider any object, mass over volume equals density. Any object, density means we all know that mass over volume. This equation is very familiar since our O levels. These are the two equations important. Directly I'm substituting. Look here. Upthrust means submerged volume. Tell me now I define total volume of the ice cube as V naught. Volume above the seawater level is V1. Then what should be the submerged volume? Submerged volume in the seawater must be V naught minus V1. I hope you understand. V naught minus V1. V naught minus V1. Right? V naught minus V1. Oh, okay. V naught minus V1. Submerged volume into density of the liquid is density of water, rho W into gravitational acceleration is G, must be equal to weight of the ice cube. Weight means mg. Mass of the ice cube, simple limb. Mass of the ice cube, simple limb. If I substitute simple limb in this equation, volume of the ice cube into density of ice cube. Density of the ice cube is rho. Volume of the ice cube is I defined as total volume of the ice cube is V naught. Entire volume is V naught. Then I can say that mass of the ice cube as what? Volume of the ice cube V naught. Density of the ice cube is rho G. Here GG cancel out. GG cancel out. Now small simplification is there. Now small simplification is there. What they're asking actually, the question they're asking, the percentage of volume above the seawater level. The question they're asking the question, they're asking find the percentage of volume of ice which is above the surface of seawater. First volume above the seawater is V1, total volume of the ice cube is V naught. I think they are asking actually in the question they are asking what will be volume above the seawater level is V1 over V naught into 100%. This is what we want to find actually. Before finding this one, you should find V1 to V naught ratio. Find V1 to V naught ratio. So therefore, what I thought of doing is, I thought of dividing all the terms by V naught. Okay. If I divide both sides by V naught, some simplification stories. If I divide both sides by V naught, see the story, V naught, I can write down. Somehow we want to finish this paper today. If I divide both sides by V naught, story. So then see here, look here, right, here, shall I move rho W that side? If I move rho W to the right side, then I can write down here V naught over V naught minus V1 over capital V naught. You can't see any. You can't see. If I move rho W to the right side, the left side is going to be V naught minus V1 over V naught. Must be equal to here V naught cancel out. Then rho over rho W. Rho over rho W. Expand the brackets and separately give the denominator to V naught and V1. Then V naught over V naught, that is 1. If you separately give this V naught denominator for V naught and V1 separately, give the denominator separately for V naught and V1. V naught over V naught is 1 minus V1 over V naught, almost close. Rho over rho W. So when I substitute V1 to V naught ratio, V1 to V naught ratio going to be how much? Then this one move to the right side, this one move to the left side. Then 1 minus rho over rho W. 1 minus rho over rho W. Done. Simplification, substitution. 1 minus density of the rho means ice cube density is 920 something. Density of water is 1000. So when you simplify, you can end up with here it's 1000. 1000 minus 920 is 80 something. That is going to be your V1 to V naught ratio. I want to find the percentage. Multiply both sides by 100%. Multiply both sides by 100%. So when you multiply both sides by 100%, we are ending with the final answer. 1, 2, 1, 2, 1, 1, 8%. 8%. I have discussed similar questions in our past discussions, right? 8%. Answer is first one. They are asking us to find the percentage of volume of ice which is above the surface of seawater. If we are correct, we haven't done any mistake. V1 means volume of the ice cube above the seawater level. V0 means entire volume of the ice cube. Correct. No issue. First one. First one. First one. Story first one. Story first one. Story first one. Time is almost 9 o'clock. First one. Next story. Next story. Next story. Next story. Then question number 8 discussed. Any easy questions? Any easy questions? Right. Question number 15. I explained already 15. Not last week. I think in the target paper 1, I have discussed 15. Raise your hands. How many we say? If I read the question number 15, they are telling that what angle below? Question number 15. What angle below? 15. What angle below? What angle below will give the minimum horizontal range? Minimum horizontal range. Okay. When an object is projected obliquely at the same speed on a horizontal ground. I have given some ideas regarding these stories on target number 1, some MCQs. Raise your hands. The right answer is first one answer. Right answer is first one answer. Right answer is first one answer. So the right answer must be second one answer. Option 2 answer. We are talking about minimum horizontal range. Option 2 answer. Option 3 should be the right answer. Option 3 answer. Answer must be option 4, sir. Answer must be option 4 answer. Answer should be option 5 answer. Option 5. Option 5. Right. Look here, this idea. I explained the story before, but I will explain again. I'll explain again quickly. Look here. The story explained. Learn. If you write, if you're writing these important points in your short notebook, I told you that short notebook must be a very small book, but it should contain some more pages. And that short notebook should be able to move easily. If you are going in a bus, even when you are traveling in a bus, you should be able to refer the short notebook. You should keep a book like that and you should refer everything short note points. If not, we don't remember. Right, look here. In a projectile motion, if the projection velocity is same, but you are changing the projection angle, then we know that when you change your projection angle by maintaining projection velocity constant, you will get different horizontal ranges. Okay, story explained. Projection velocity you maintain constant, you are changing your projection angle theta. Then you are getting different horizontal ranges. Then you are getting different horizontal ranges are. I explained for you guys. You will get the maximum horizontal range when the angle is exactly 45 degrees. That's what I explained. I don't explain why it is. When the angle is 45 degrees, important point, your R will be maximum. Horizontal range will be maximum. Right? Maximum. Next story is, the next story is when you increase your projection angle from 0 degree to 45 degree. When you are increasing your projection angle from 0 to 45 degree, your horizontal range R increases. Right? When you increase your projection angle from 0 degree to 45 degree. 0 degree to 45 degree. Then I said that your horizontal range also increases. That's why when the angle is 45 degree, R is maximum. This story. Also, I told you that there are two possible projection angles for a same horizontal range. That story. There are two possible projection. There are two possible projection angles for a same horizontal range. If the, let's say now you are getting horizontal range R for the position angle theta, you will get the same R for the position angle 90 minus theta. That's to also explain, right? Same R, two possible projection angles. Same R, two possible projection angles. If one angle is theta, other angle is 90 minus theta. This is the summary. I explained many times. No time. No time. No time. So we have to finish. So when we are discussing 50 question is the trouble. Very tiredful session is. Okay. Now based on this, you can tell me the answer. Now see, 30, 40, 45, because we know 45 can't be. Why? Because they are asking about under constant projection velocity. What is the minimum horizontal range? You want to find the minimum R, then you know that at 45 degree, R is maximum. And you also know that when your position angle is lower, in between 0 to 45 degree, when your position angle is lower in between 0 to 45 degree only, your horizontal range will become minimum. So then when you consider 30, 40, 60, we know 45 can't be, 30 and 45. 30 and 45. Right? 30, 40, 30, 40, 60. Right? So when you compare 30 and 45, right? When you compare 30 and 40 degrees. So we all know that, sir, since the 30 degrees and 45 degrees are less than 45 degree, since 30 is the smallest projection angle, R is smaller, horizontal range is smaller when the angle is 30. When you compare with 40, 30 has the lesser projection angle. Therefore, horizontal range is smaller when the angle is 30. When you compare 30 and 40. Then we can eliminate 45. We can eliminate 40. Then we have in our hand 30 degree, 60 degree, 75 degree. I told you that this condition, same horizontal range, you will get in two different projection angles. When the angle is theta also, you get same R. When the angle is 90 minus theta also, you get the same R. Just consider 30. If you are, we removed 45 degree and 40 out of 5, then we are having in our hand 30 degree option 1, option 4, 6 degrees, option 5, 75 degrees. When you consider 30 degree, let's say horizontal range is capital R. What is the other possible angle which gives same capital R? 90 minus 30, 60. Then you understand option 1, 30 degree, and option 4, 60 degree, both of them will give the same horizontal range. Then I think if both of them are same, both of them giving same horizontal range means we can't take the answer as option 1 or option 4 also, right? 75 degree. So when you someone will easily misunderstand when the angle is 75 degrees, angle is large. You taught us angle is larger, R is larger, right? So then when the angle is 45 degree, it's larger than 45, sir. Then maybe maximum horizontal range belongs to 75. But you want to understand what is the other possible angle? 75 degree, right? Now let's say now horizontal range, when the angle is 75 degrees, capital R. Same capital R will be given when the angle is 15 degree. 90 minus 75 degree, 15 degree. 15 is an acute angle less than 45. 15 is less than 45 degree. 15 is the minimum angle in this scenario. When the angle is minimum, horizontal range is minimum. Answer is 5. Nice question. Nice stories. Nice question. We'll take a break at 9:30. Right? Okay. Then 16 is easy. 16 easy. 16 easy. Learn from questions. Right? Learn from questions. Today itself, after class finishes, you should read these questions once again. Once again, read it. It's a must. It doesn't matter what is your marks. Doesn't matter. Should redo it. It's a must. It's a must. Question number 16. Story. What they're asking? 16. 16 they're asking. When water is filled to a height of 8 centimeter in a container at atmospheric pressure of 10 water meter, what is the total pressure in newtons per meter square at the bottom of the container? At the bottom of the container, very simple story. I explained that how to convert water meters into pascals. That story, the theory classes I explained. Now, normally I explain all the theories properly. 10 water meter, 80 centimeter. 10 water meter, 80 centimeter. Right. Water is filled in the container up to a height 80 centimeters. H is 80 centimeter. H is given. 80 centimeters means we all know that 0.8 meters. And we all know that I want to find the total pressure at a point at the bottom. It's a point capital E. I want to find the pressure at the bottom point capital E. We know that above the water there is atmospheric pressure. Atmospheric pressure is, let's say, pi. They have given atmospheric pressure is 10 water meters. How do you convert water meters into pascals? Same story. How do you convert water meters into pascals? Water meter is a unit to measure the pressure, like mercury meter, mercury millimeter, mercury centimeter. Water meter also a unit to measure the pressure. If you want to convert water meters to pascals, you want to multiply by density of water into, density of water into gravitational acceleration. You want to multiply by density of water into gravitational acceleration. The story. Also, we know if you want to find the pressure at point capital A, that's very straightforward story. PA must be equal to hydrostatic pressure means H rho G. H rho G, I don't explain why it's H rho G, plus the above the water there is atmosphere. Atmosphere produces kind of a pressure on the water surface, that is pi. H is how much? 0.8 meters. Density of water is 1000, even though they give 1000. Gravitational acceleration is 10 plus atmospheric pressure is 10 water meters. 10 water meters. How do you convert to pascals? Multiply by density of water 1000 multiply by gravitational acceleration 10. This is a story. Substitution. Substitution part, story. Substitution part, story. Story. Right. Simplify. So we simplify our answer. Here we are writing here 10 right. Here what can I do? Here if I take I can take 10⁴ as my common factor out. 10⁴ as my common factor out, then here we are getting 0.8 and 10. 10 plus 0.8 means 10.8. 10.8. Final our answer is I think 1.08 into 10⁵ Pascal something. Any answer like this? 1.08 into 10⁵ Pascals. Any answer like this? Any answer like this? Any answer? Any answer? Any answer? 1.08 into 10 to the power. Oh god, shit. No answer. No answer. Because yes, that's an answer. 10.8 into 10 to the power 4. 10.8 into 10 to the power 4 is the answer. Answer going to be third one. Third one is the answer. Third one is the answer. Next story. Next story. Then 15 discussed, 16 discussed, and 18 then 17. 18. A solid cylinder of moment of inertia 8 kilogram meter squared is rotated about its axis at an angular velocity of 600 radians per second and brought to rest. That means initially that object rotates under an angular velocity omega 0 is 600. Final angle lost becomes 0. Finally it comes to rest, brought to rest by a constant torque of 160 Newton meter. what is the time taken? What is the time taken for it to come to rest from the moment of torque is applied? From the moment of torque is applied, right? Not difficult story. We'll see. Question number 18. Next story. Next story. Question number 18. That's an object. Initial angular velocity omega naught is given. Omega naught is given 600 rad per second something. Final angular velocity omega is 0. Omega naught is 600. Omega is 0. That means we understand in the clockwise direction there is a angular deceleration. In the clockwise direction there is a angular acceleration. That means in the anti-clockwise direction there is an angular acceleration. In the anti-clockwise direction we understood that there is an angular acceleration alpha. Angular acceleration alpha. In the anti-clockwise direction there's an angular acceleration alpha. So the reason behind the reduction of angular velocity from omega naught to 0 is, the reason is because there is a torque acting on the object not supporting the rotation. It is rotating in the clockwise direction, but the torque is not supporting the rotation. That means torque must be acting on the object in the anti-clockwise direction. Then only its angular velocity decreases. If the torque is acting on the clockwise direction, it supports the rotation. Then further angular velocity should increase. Anti. The torque acting on this object is tau. So we learned like F equals ma equation. The resultant force F must be equal to mass into acceleration. In rotational motion, there is a similar equation. Tau equals I alpha. Tau equals I alpha equation. So we all know tau equals I alpha equation. Tau equals I alpha. And shall we find the torque? Sorry, shall we find the angular acceleration story? Alpha. They have given the torque is how much? Torque is given as 160, and moment of inertia 8. Right. Since they have given torque is 160, moment of inertia 8. 160, I is 8. We can find the alpha. Alpha should be 20 something. Alpha is 20. If you know alpha is 20 rad per square second. Don't forget the units. Right, rad per square second. I know omega naught, I know omega, I know alpha. I want to find the time simple t. The best angular motion equation. Just think omega naught as u, omega as v, alpha as a, time as t. The best linear motion equation is v equals u plus at. Likewise, the best angular motion equation going to be omega equals omega naught plus alpha t. Story explain. Omega equals omega naught plus alpha t. Omega equals omega naught plus alpha t. Story. Omega equals omega naught plus alpha t. Final angular velocity is 0. Initial angular velocity is 600 something plus right. I'm applying the angular motion equation in the clockwise direction. Direction of rotation is clockwise, but the acceleration is in the anti-clockwise. Therefore, minus alpha value is 20. I want to find the simple t. I want to find the time simple t. Simple t going to be how much? Simple t going to be, as per my understanding, simple t is 30 something. Simple t going to be 30 seconds. If I'm wrong, tell me. If I'm wrong, tell me. Simple t is 30 seconds. 30. Right answer. The right answer must be. Fourth one. Next story. Right. Next story. Remember now, this question number 20 is very simple question. It's not difficult. Question number 20 is seem like very complex but very simple question. Question number 20. A length of a composite string made by tying together a thicker string of mass simple limb and a thin string of mass simple limb knot. Thicker string mass simple limb, thinner string mass simple limb knot is 2L. is 2L. That means thicker string length also simple L, thinner string length also simple L. The total composite string length is 2 simple L. Thicker mass simple M, thinner mass simple M naught. One end is tied to the fixed point and an object of mass capital M is suspended from the other free end. What will be the tension capital T at point capital A? Tension capital T at point capital A, where the two strings are connected. Very simple. Very simple story. Look here. This story. A thicker string. And a thinner string. And the mass is capital M. Remember, thinner string does not have any mass. This mass is capital M. But thicker string has a mass, that is simple M. No, they mentioned, they have given a mass for thinner string also. They have given a mass for thinner string also. Thinner string mass is how much? Simple M naught. Thick string of mass simple M and thin string of mass simple M naught. Yeah. Thinner string also has a mass simple M naught. Simple M naught. What we want to find actually, we want to find the total tension, the tension force at point capital A. Remember, point capital A. Remember the story. Who contributes for the tension? Which masses contribute for the tension at a point? Remember, anything below that point, the total mass below that point, the total mass below that point contributes to the tension. Since I want to find the tension at point capital A, what is the total mass below point capital A? Mass of the thinner string simple M naught plus this object mass capital M. Total mass below point capital A simple M naught plus capital M. Therefore, what is the total tension? Simple M naught plus capital M G. If they are asking us to find the total tension at point capital B somewhere here, the total mass below point capital B is thicker mass simple M plus thinner mass simple M naught plus capital M total G. Therefore, answer is tension at point capital A going to be capital M plus simple M naught, capital M plus simple M naught G. This is the answer. Question number 20, answer is capital M plus simple M naught G. Second one is the answer. Very simple logic. It's a very simple logic. 25 is very simple. 23 is very simple. 23 is very simple. 23. Question number 23. 23, what they are asking? They are asking 23, as shown in the figure, 3 books X, Y, and Z. 3 books X, Y, and Z placed on a horizontal surface have masses 0.4 kilogram, 0.5 kilogram, and 1 kilogram, respectively. What is the net force acting on the book Y? Net force means resultant force. What is the resultant force acting on the book Y? Very simple. Since book X, book Y, book Z, the table, all of them are under equilibrium. When you separately consider book Y, the resultant force acting on the book Y must be 0. No need to do any calculation. If that books are under equilibrium, if books are not accelerating, if the books are not decelerating, the resultant force acting at any book must be 0. Direct answer is 5. Answer is 5. Question number 23, answer is 5. And this question, 22, I think yesterday theory class, yesterday Sunday theory class I taken to Friday ni, temporary, only 1 week. Thereafter, as usual, Sunday only I doing the class. Then question number 23. 22 ni. Question number 22, they are asking apparent displacement. I am not explaining anything. I directly write the equation. Yesterday I explained. Question number 22 something. Question number 22, we want to find the apparent displacement. 22, there are 3 mediums. I told you that it doesn't matter where is your object. When the object is exactly at the bottom or below the bottom, or I told you that apparent displacement remains same. That was the last story we discussed yesterday, theory class. as shown in the figure. An object is viewed in the air above the water level, right? Okay. Apparent displacement of the image given by glass, air, water. Glass, air, water. Three mediums. Surrounding medium is air. Glass, air, water. Three mediums. Total apparent displacement, let's say capital D, simple D. Total apparent displacement, simple D. Let's consider glass medium. Glass medium thickness. Thickness is, we all know, it's 9 centimeter. 9. 1 minus surrounding me refractive index A, and it's 1 over refractive index of glass. How much? Refractive index of glass 3 over 2. I am not explaining anything because yesterday I have done this story and we have done questions. Plus, if it is AR 0 only, but we'll do it. AR means thickness of the AR medium is 5 centimeter. Thickness of then 1 minus surrounding medium is AR over refractive index of AR is 1, 1 minus 1, 0, which is 0 plus then the water medium. Water medium thickness 4 centimeter, 1 minus refractive index of surrounding medium is 1. Refractive index of water is 4 over 3. Story. Simplifications here denominator is 3. 9 over 3 means 3 centimeter something, 3 plus is 0. Here 4 something. Here 4 minus 3 means 1. It's 1. Here it's 1. Here I think it's 1. 4. It's 1. Answer is 4 centimeters. I'm not explaining anything because yesterday I have done this. This story also done, explained. Right? Now, past the discussions, I just take time and explain, but when it comes to targeted discussion, upcoming days, I'm accelerating more because upcoming days, when in the case that if you are discussing 50 MCQs, just imagine, then we need to do 6-hour class as soon as, without skipping. I will try maximum to explain everything, but want to accelerate. If I'm discussing a full paper per week, imagine to discuss 25 MCQs, we are taking 3 hours at least. If you want to discuss a full paper means 50 MCQs, 4 structured, 8 essays. Within a week, full paper discussion. Right? It's really challenging. Next March onwards, we might, if we can finish syllabus at February, we might start discussing full paper discussions. Then no theory class, you have only paper class and revision. Okay. Hope everything will go properly. Answer is 4 centimeter in the first one. 22nd answer is first one. 22nd answer is first one. 9:30 break. 10 minutes to go. 10 minutes to go. 23 also done. 24. I have discussed similar story in target paper 1. Let's see when I mark in the way. Let's see how many of you learned something from target paper 1, and let's see how many of you could do this question correctly. 24. You know that in my office, I will tell you now, my boss. Now I'm also working as an engineer. Now, like how you do mistakes, you are a student, I'm a teacher. I'm teaching you the theory, I'm teaching you the right thing. You are doing the mistakes in the beginning, but you should not do the mistakes. You should not do the same mistake. Likewise, I'm also working, so then I also have a boss. So then I also learning because it's been only 1.5 years since I am working as an engineer. So then my boss told that story like this. I also do lots of mistakes because when I do a mistake, it's very serious. Just imagine, drawing, or if not, when I doing a project, if I do a small mistake, the impact is billions for the company. So then one day I made a mistake and I was fully upset and I don't know what to do. Then my boss called and what happened? Then I told this is what happened. This was the issue. Then boss told that doing a mistake is normal, but you should not repeat the same mistake. You can do another mistake, but you should not repeat the same mistake. Right? Same story I want to apply for you also. Therefore, thereafter, I never did a mistake. Till now, I haven't done a mistake, same mistake. So for you also, I'm telling, do mistakes. Okay. But please don't do the same mistake again. Then it's not okay. Right? 24. Uniform thin circular plate of mass simple limb, radius r, if led just upward by a horizontal force capital F. as shown in the figure, minimum value of capital F. This seems like very easy. We'll try. We'll give a small try. 24 will give a small try. A small try. Center and right. This gap is simple edge. This gap is simple edge. And the force is capital F. The applied force. I'm not explaining the story. Target number 1 also I discussed. So therefore, I'm not doing a big explanation. But see, same question they can ask different manner. Capital H, simple R. Capital H, simple R. Capital H. Right. This is capital H. This gap is here capital H. I hope you can see the story. This is simple H. Simple H. Look at this. This is the radius. Simple R. Simple R. Simple R. Shall we mark the forces? So when the moment this object is taking the step, when the moment this object is taking the step, when the moment this object is taking the step, I told you that there won't be any contact between the object and the ground. Then the normal reaction force acting on the object at this point becomes zero. That story. When the moment it is taking the step, normal reaction force is zero. Okay. That story, one important point is the important point. If I mark if you mark the forces acting on the object, the total weight, the weight force, the weight of the object, mg acting downwards. Mg acting downwards. Mg. The normal reaction force acting on the object at this edge, that is, let's say capital R something. And this force capital F. Right? So then actually there are 4 forces. One is capital R, other one is capital F, other one is mg, and other one is the normal reaction force acting on the object at this point upward. I told you, in the moment you are taking the step, this object is taking the step, that normal reaction force becomes zero. Why? There won't be any contact between the object and the ground. The story explained already. Now I told you, even though it's taking the step, we can consider this object is under equilibrium. Then we know if it's under equilibrium, today only I explained that resultant torque must be zero. When you consider any point, resultant torque must be zero. If it is under equilibrium, you can consider any point, resultant torque must be zero. Resultant torque must be zero. So you can consider this point. This point is as a point capital A. When you consider point capital A, resultant torque must be zero. That means clockwise torque must be equal to anti-clockwise torque. Then only resultant becomes zero. If the clockwise torque equal to anti-clockwise torque, only resultant torque can be zero. Clockwise torques around point capital. Take the torques around point capital A. Force into, we know torque means force into perpendicular distance. We know torque means, we all know force into perpendicular distance, simple T. This story we know. This story we learned. This story we know. This story we know. Then the capital F creates a kind of clockwise torque around point capital A, F into perpendicular distance. How can I find this distance? How can I find this distance? Perpendicular distance from point capital A, perpendicular distance. I want to find this gap. How can I find this gap? How can I find this gap? This gap, I think I want to consider. Look here. Here to here, radius simple R. This gap is simple R. This gap is simple H. This gap is simple R. This gap is simple H. This gap going to be simple R minus simple H. This gap is, we all know that simple R minus simple h. Same story. This gap. This is simple r radius from the center to here. Simple r radius. This is capital H. This gap going to be simple r minus capital H. Simple r minus capital H. Therefore, when you consider capital A force, the perpendicular distance to capital A force from point capital A, this gap going to be r minus h plus r minus simple h. 2r minus capital H minus simple h. Nice story. Clockwise torque. F creates a clockwise torque around point capital A. That is to C. This question is different than that question. 2r minus simple h minus capital H is the clockwise torque produced by capital F. Any other clockwise torque? This capital R create, because since I taken the torque around point capital A, important points. This is an important point. Short note point is a short note. R when it's taking the step, contact becomes 0, then normal reaction becomes 0. And since I'm taking the torque around point capital A, this capital R does not create any torque around point capital A. Important point. Important point. Then F creates a clockwise torque I found that must be equal to torque produced by mg. Mg creates anti-clockwise torque. Mg creates anti-clockwise torque. Mg must be equal to mg into mg creates anti-clockwise torque. Mg into perpendicular distance to mg from point capital A. I want to find this gap. Perpendicular distance to mg from point capital A. I want to find this gap. So I do the small triangle for our understanding. Is that small triangle? Is your point capital A? The radius simple r. The radius simple r. The radius simple r. And this gap, see the gap? And this gap is already we found. This gap is simple r minus h. This gap is simple r minus h. But what I want to find the perpendicular distance to mg from point capital A. I want this gap. I want to find this gap. This is the perpendicular distance. So this gap is simple x. This gap is simple x. Pythagoras. See, nice story. Pythagoras means we know r squared must be equal to r minus simple h squared plus simple x squared. Simplification as simplification. Please someone tell me, including this question, how many finished so far? We'll take a break also. How many finished so far? Including this question, how many finished so far? Out of 25. Expand the bracket r squared minus 2r simple h plus simple h squared plus simple x. So when you substitute simple x going to be r squared minus r squared cancel out. 2rh minus simple h squared something root 2rh minus h squared whole root. How many finished including this? How many finished? 14. Okay. We'll want to go. We'll take the break and we'll do it. We'll get the answer. I think the answer is now they didn't expand it. So in the given data, I feel like they haven't expanded this. They haven't expanded this bracket. The given answers, I think. Therefore, when you substitute x we can write down x as r squared minus r minus simple h squared whole root. These are x. Then here, okay, r squared minus r minus simple h squared whole root. So therefore, when you subject capital F, your capital F going to be mass is capital M. Mass is capital M, right? Simple M, capital M doesn't matter. Okay. Simple M G, capital M G, okay, whatever. Simple M, capital M doesn't matter. Capital M G r squared minus r minus simple h squared over here this one 2 simple r minus, take this minus as your common factor out. H simple H plus capital H. Simple H plus capital H. Nice story. Nice question. This question answer is second one. Second one is the answer. 14 discussed. 9:35. We'll take a break or any easy question to finish 50. We'll take a break. We'll take a break. Up to now, everything is crystal clear answer. Up to now, everything is crystal clear answer. Crystal clear answer, everything. Everything is crystal clear answer. Everything is crystal clear answer. Learn, 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 learn. More the questions you do, you will win more. Right. Time is 9:33. We'll assume 9:35. Let's come at 9:45. Ni. Come at 9:46 or 9:47. 9:46. Ni. Come at 9:46. So maybe 47. Right. Yes. 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 We'll discuss. We'll discuss further. We'll discuss further. Then question number three. Question number three, statement questions. Last 11 to go. Question number three. Three statements question A, B, C. Statement A, statement B, statement C. Uh, okay, consider the following expressions regarding the motion of an object. Statement A, when an object moving with constant velocity, its speed can be changed. When an object moving with constant velocity, its speed can be changed. Is it correct? Is it correct? Velocity is a vector, speed is a scalar. Remember, just consider an object. That object moving under constant velocity, that means remember, this object is moving to the, for an example, velocity is a vector. If the object moves under constant velocity means direction also won't change. Direction right side means it's keep on traveling the right direction. And magnitude of the velocity is also same. Remember, always remember speed means what? Speed means magnitude of velocity. Remember speed means what? Somebody write a short note point. Speed means magnitude of velocity. Speed means magnitude of velocity. Since this object moves under constant velocity, magnitude of velocity constant, that means this object speed also should be constant. Statement capital is correct. If an object moves under constant velocity, its speed definitely should be a constant, right? Statement capital B. Statement capital B, they are telling. Statement capital B, they are telling. When an object moves with constant speed, its velocity can be changed. Statement A, I made a mistake. When an object moving with constant velocity, its speed can be changed. Wrong. Speed must be constant. Speed must be constant. Okay. B statement, when an object moving with constant speed, its velocity can be changed. That's correct. You know why? Let's say speed is a scalar, right? Just consider an object is moving with a constant speed. That means 5 ms minus 1. So after some now earlier this object was moving to the right side direction with 5 ms minus 1. Then also speed is 5 ms minus 1 scalar. When this object is going backward direction, returning back under same speed is same. 5 ms minus 1 before, 5 ms minus 1 after, but the directions are different. Direction different means we know that. Velocity is a vector. Velocity depends not only with the magnitude, velocity depends on direction. Earlier velocity is right side direction phi, and now velocity is left side phi. So therefore statement B, they are telling, when an object moving with constant speed, its velocity can be changed. That's correct. It's correct. Velocity has changed. Even though this object is moving under constant speed phi, when direction changes, velocity changes. B is correct. Statement C, they are telling an object with constant speed cannot have acceleration. Remember, an object with constant speed cannot have acceleration. That's wrong. An object with constant speed cannot have acceleration. That's wrong. You know, acceleration is a vector. Acceleration is a vector. Remember, that means, let's say now there's an object. That object is taking a bend. That object is taking a bend. Magnitude of the speed is same, 5 ms minus 1. Remember, speed is 5 ms minus 1, same speed. But look at the direction of velocity. Now this object is moving under same speed, 5 ms minus 1, 5 ms minus 1, 5 ms minus 1. But when it is taking a bend, you understand that direction of the velocity changes. Okay, if they have given an object moves under constant speed is 5 ms minus 1. Yeah, speed is same at any point when the object in the bend. But the problem is just consider its velocity. Yeah, magnitude of the velocity may be same. As the object in the bend, magnitude of the velocity may be same, 5. But as it taking the bend, direction of the velocity changes. Remember, in a vector, remember, when the magnitude changes or when the direction changes, that vector changes. In this scenario, even the magnitude of the velocity is same phi, since the direction of the velocity changes, that velocity changes. Remember, when velocity changes, velocity change with the time means that's an acceleration. What is acceleration? Rate of change in velocity. Whenever there is a change in velocity, there is an acceleration. Statement 3 they are telling an object with constant speed cannot have acceleration. An object having constant speed can have a different velocity. That means can have an acceleration. So therefore statement C is wrong. It's a nice question, only B is correct. I don't know how many of you got this correct. If you got this question correct means you are on a track. You are on the right track. Answer is number 2. Question number 3, answer is number 2. Then next story. Number 2 discussed. Then 1, 2 discussed, 3 discussed, 4 done, 5 done, 6 done. Then 7 done, 8 done, 9, 10. 9, 10, 11. Okay, 11. Go to 11. Statement question. Sometimes I don't know how many of you really get my stories. If you have doubt, ask. Huh? Because you want to finish it also. Nice stories. If you can maintain a good short notebook, if you are coming to discussions properly, if you're writing the papers properly, no one, I guarantee. I'm telling I guarantee for your B and E. I'm guarantee. I'll guarantee. Do what I say. I guarantee you are B or E. I'm sure you won't get C, you won't get S, you won't get W. Getting B or A. Based on your hard work, I can assure you will get A. Right? I'm guaranteeing. You want to follow it. Two identical balls P and Q are thrown upward with same velocity U. Capital P is thrown as it can rotate and capital Q is thrown as it cannot rotate. Neglect the effects due to AR. That means you want to neglect AR resistance stories. When the objects are moving upward, you want to assume AR resistance forces all are negligible. Right. Option A, they have given some statements. Option A. Two balls. See the story. It's vertical motion and the grid story only. Object capital P. See the story. When you consider object capital P, identical balls, same mass, same volume, same density, identical balls, P and Q are thrown upward with same velocity. Projection velocity same as U. So all of them are moving under same projection velocity. But the thing is, capital P is thrown as it can rotate. Now, what you have done is, while rotating capital P only, you projected capital P vertically upwards. So yeah, this capital P is following a vertical motion while following a rotational motion. While rotating only, capital P is going in upward direction. While rotating only, capital P is going in upward direction. Right? New nice stories are there to learn. Nice stories. At the maximum height. Right? I will tell you some stories. While rotating only, this capital P is going upward direction. So we'll come to capital Q. When talking about projection of capital Q is thrown as it cannot rotate. Only you just thrown upwards without rotating capital Q. You just thrown capital Q upwards under projection velocity U. Capital Q. Right, sir. I understand what you are coming to tell. Nice stories. This paper, target paper class is result making class. Believe me, if I do this paper class properly till your A-level exam, let's say you're doing paper A-level exam in August, still I do the paper class properly till July. This is a result making class. English medium, can't find a class like this. English medium. I can guarantee. Just find a class and tell me. Can't. That much I'm confident. Right? Okay. So this is just a normal vertical motion question. Now we know that normal vertical motion, position velocity is u. As the object goes in upward direction, what will happen to the velocity? Velocity decreases, 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 decreases at the maximum height. Velocity becomes zero. At the maximum height, we all know that velocity becomes zero. Upward direction, velocity decreases. I'm talking about linear velocity. Linear velocity, upward direction decreases, decreases, decreases. At the maximum height, velocity becomes zero. When talking about point capital P, see the story, object P story. Object P also following a vertical motion. As it goes upward direction, it's linear. Its vertical velocity decreases, decreases, decreases. At the maximum height, yes, vertical velocity becomes zero. But the problem is, this object capital P keep on rotating. No matter object goes upward direction, no matter object reaches even the maximum height, at the maximum height also, this object is keep on rotating under same angular velocity. Let's say when the moment you are projecting the object, it was rotating under angular velocity 5 rad per second. When the object is at here, at the maximum height also, its angular velocity is a constant. Why? They are clearly mentioned no any air resistance there. Then there won't be any resistant torque acting on the rotating object. If there is any resistive torque acting on the object P, its angular velocity same as omega, even at the maximum height, angular velocity of the object is omega. This is the story you want to know. Given statement, given statement, given statement, given statement. Statement capital A. Statement capital A. Right. Statement capital A. Statement capital A. 10 o'clock. Statement capital A. I think this is 15 done. 16. Last 9 to go. Last 9 or 8 to go. Statement capital A. Statement capital A. We'll try to finish at 10:30. Capital A statement is telling that P will go higher than Q. Remember, since both are identical, doesn't matter even they are identical or not identical, doesn't matter. Since both of their rotational velocity is same, they projected under gravitational acceleration. Remember, both it doesn't, even though it's rotating, even though object capital P is rotating, remember, their vertical heights should be same because same projection velocity, right? Under gravity, you are projecting these two objects. Therefore, remember, P and Q, both of them should have same vertical height. So P will go higher than Q. It's wrong. Some people might think that. In the beginning P is rotating. So in the beginning P has linear kinetic energy as well as rotational kinetic energy. When it comes to Q is only having linear kinetic energy. Therefore, sir, since P is having a larger energy than Q, P can go larger height. That's wrong. The reason is rotational kinetic energy is same, right? Throughout the motion, rotational kinetic energy not reduce. Even the maximum height, rotational kinetic energy is same. So therefore, remember, heights won't be changed. Same position velocity means same height. So P will go higher than Q. It's wrong. Option B. Kinetic energy of P and Q are zero. Kinetic energy of P and Q are zero at the highest point. You will think it's correct. Most of you think it's correct. They're telling kinetic energy of P and Q are zero at their highest point. That's wrong. That's wrong. Why it's wrong? When you consider Q at the maximum height, linear velocity also zero. No rotational motion for Q. Yes, kinetic energy of Q at the maximum is zero. But when it comes to P, yeah, linear velocity is zero. Linear kinetic energy of P is zero, but still at the maximum height, Q is keep on rotating under omega angular velocity. Therefore, even the object P at the maximum height has a rotational kinetic energy. They haven't mentioned specifically rotational linear. They are telling kinetic energy. When you consider object P, still it has a rotational kinetic energy at the maximum height. P has a kinetic energy at the maximum height. Q's kinetic energy at the maximum height is zero. But statement B they are telling. 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 Kinetic energy of P and Q are zero at the highest point. Wrong. Statement B also wrong. Nice questions. So you can improve your knowledge. P and Q will reach the flow at the same time. That's correct. P and Q will reach the flow at the same. That's correct. Because why? Same. Because for the vertical motion, this one's rotational motion is not any impact, right? At the same time only both of them obtain maximum height. So both same time only they will return back to the same ground. C is correct. Therefore, only C is the answer. They are asking the right answer of the above statements. Right answer is third one. Only C is true. Option 3. Option 3. Option 3. That question number 11 also done. 11, 12 story. Question number 12, important point is there. Question number 12 is an important point. You know that wavelength. Wavelength. I don't know how many of you have written important points from this. Important points. Okay, I'll give homework. Today I'll give homework. The homework is from this today's session, what you felt important. Should redo the questions again. It's must. But I don't ask that. But today's session, after class finishes, take some time, man. Should send before 1 a.m. Even you don't send, I don't going to check. It doesn't matter. It's your responsibility to do it. If I tell something, don't do it. Today's discussion, what you felt important. Now I told some these are important also. I mark red color star, and I told these are important, write down. What I told and what you felt important. Everything brief, target paper 2, important stories we discussed. You should send me a story today after class finishes. Take time till 1 o'clock, 1 a.m. Till 1 a.m. take a time. Send me. I can't come and I can't monitor you because it's an online class. If you come to my physical class, I will check everything properly. Question number 12. Right. A wave took 4 seconds time to travel 180 millimeter. Now we can say that wave moves under normally waves move under constant velocity. That's the way consider. Now they have given time taken and the distance traveled by the wave. Why have they given time and distance? To find the wave velocity. So we know velocity equation, constant velocity equation is V equals distance over time, velocity equals displacement over time, or whatever. S over T or whatever. Then you can find the wave speed, wave velocity is how much? 180 millimeters. Sorry, 80 millimeters. 80 millimeters if you convert to meters, multiply by 10 to the power minus 3. Multiply by 10 to the power minus 3. Time taken is how much? Time taken is going to be 4 seconds. Divide by 4. Then our answer going to be 80 over 4 means 20. 20 means 0.02. 1, 2, 3. If I'm wrong, tell me. Sorry, speed, my bad. Speed of the wave is distance 80 millimeter time 4 seconds. Speed is 0.02 ms minus 1. If I'm wrong, tell me 0.02 ms minus 1 speed. Speed is 0.02, correct? 20, yeah, 1, 2, 3, correct, right. If the horizontal distance between two particles with a phase difference pi over 2 is 5 millimeter. If I draw a wave, look here. Learn the stories. So you will cover some theory points by doing questions. If I draw a wave, is it a bad wave? Remember, these are crests. When you consider these are crests and these are two troughs. Remember, this is one complete waveform. Is one complete waveform. Remember, first story, when you consider one complete waveform, this story very important. Short note point. These stories are short note points. When you consider one complete waveform, short note point, the phase difference is 2 pi. The length is wavelength. One complete waveform, the distance is wavelength. That story you know. But the new story is phase difference. When you consider one complete waveform, phase difference is 2 pi. 2 pi means 360 degrees. Phase difference is 260 degree when you consider one complete waveform. If not, when you consider two adjacent crests phase wavelength, when you consider two adjacent crests, the gap is wavelength, the phase difference is 2 pi. When you consider two adjacent troughs, gap is wavelength, phase difference 2 pi. Okay, that story remember. That story you know, you remember. So if they ask you that, if they have given in the wave, there are 2 points having phase difference pi. If they have given in a wave, when you consider two medium particles in a wave, when you consider two medium particles having phase difference 2 pi, then one particle is here, one particle is here, right? That story. If they have mentioned phase difference between two particles in a waveform is 2 pi, this is particle 1, this is one particle, this is one particle, right? This one is one. If they mention that the phase difference between two particles in a waveform is pi over 2. Pi over 2. Sorry, pi means this particle is particle. What is the gap there? One complete waveform, the gap between the particle is lambda. Two particles having a phase difference pi means gap is lambda over 2. Short note point. Short note point. Short note point. When you consider two particles having a phase difference pi over 2. Pi over 2 means maybe this point and this point. This particle maybe. The gap is going to be lambda of 4. The gap is going to be lambda of. This gap is lambda of. Short note point. Learn. This is learn. Lambda of 4. Oh, I don't have a time. If not, I will talk something. No time. If I talk, no time. Right, okay. Now they have given horizontal distance between two particles with a phase difference pi over 2 is 5 millimeter. Right, that means this gap is 5 millimeter. Lambda over 4 is 5 millimeter. That means lambda over 4 is 5 millimeter. I can find the wavelength. Lambda over 4 is 5 millimeter. Then the 5 millimeters, if you want to convert to meters, multiply by minus 3. 5 millimeters, if you want to convert to meters, multiply by minus 3. Then what is your lambda? Lambda is 20 something. Lambda going to be 20 10 to the power minus 3 meters. Okay, I found the wavelength. I know the speed is 0.02 something. They are asking the frequency. V equals F lambda equation. V equals F lambda equation. V equals F lambda. Then frequency, I want to find frequency simple F. Speed is 0.02. Speed is 0.02. Right, speed is 0.02. If not 20 into 10 to the power minus 3. See. 0.02 means 20 into 10 to the power minus 3 speed. 20 into 10 to the power minus 3 over wavelength is also how much? 20 into 10 to the power minus 3. Answer is 1 hertz. Nice question. Nice question. You can learn something. Have a doubt, ask. Huh? Question number 12 answer is 1. If you have a doubt, ask. I am in a hurry of finish questions. Nice question. Can learn a lot. Today's paper also you can learn a lot. Today's paper also you can learn a lot. This is a proper paper class. It's a proper paper class. Marking scheme of target paper 2 has given for the typesetting. I think I will get by tomorrow or day after tomorrow. Then I will get the marking scheme also. Also, I send the PDF of your workings in target paper 2 today, tomorrow night. Maybe then you can correct your mistakes and all. Then in the post, I will post your. Also, better, you know, when I take the printouts of some of your papers, it becomes black color. So you know that if you have the cam scanner now you can scan and you can send. Then it will be very nice. If you just take photos and if you just convert to PDF, if you can use a cam scanner and if you can, if you don't know, ask me, I will help you how to do that. If you use cam scanner and if you take the scan of that and if you can send me, then when I take the print, I can get a white color papers. If not, if I take a print, it will become black color. Then okay, 12 done. Pending. Then 12 done. 13. Learn these questions. Learn from these questions 13. Learn from these questions 13. Huh? Question number 13. Story. Now this is also nice question. No, not difficult. Nice question. When two tuning forks A and B are sounded separately, the variation of the a displacement of an air molecule with time due to the sound waves generated in air are illustrated in the nearby graphs. There are two sound sources. When you vibrate each sound source separately, so their displacement time graph is given, right? First diagram may be the tuning fork A's displacement time graph. Second graph may be the displacement time for tuning fork B, right? Okay. Okay. What is the beat frequency formed when both tuning forks are sounded together? Because we know that when there are two tuning forks vibrated, when there are two tuning forks having very close frequency, when there are two tuning forks having very close frequency vibrated together, we know that beats will occur. The beat frequency, we know beat frequency means if you take the modulus of difference of the frequencies of tuning fork A and B, that is the beat frequency. If I say beat frequency, tuning fork A frequency minus tuning fork B frequency, that is the beat frequency. That is the beat frequency. Yes, right. Okay, right. Okay. Now you just refer the diagram and tell me. Now they have given in the displacement time graph. Quickly, can you check the how many full wave cycles are there? When you consider, look at that both the displacement time graphs till 0.25 second, how many full wave cycles are there? This is a one full wave cycle. If the wave is starting from this is one full wave cycle. Okay, just tell me in that diagram, first displacement time graph, how many full wave cycles are there? Can someone tell me? Right? Wave cycle means this is one full wave cycle, one cycle. If the wave starting from here, this is one cycle. How many full wave cycles are there? The first diagram. Someone tell me. How many wave cycles are there? Someone tell me. First diagram. Everyone go and tell me. The first diagram. How many full wave cycles are there? One, two, three, four, five, six, seven, eight. Hands up who agree there are 8 wave cycles in the first graph. Hands up. There are 8 wave cycles. There are 8 wave cycles. Hands up. There are 8 wave cycles. Then what is the frequency? Frequency means within 1 second, how many wave cycles are there? How many wave cycles happen within 1 second is frequency. We calculated 8 wave cycles. That is happening in 0.25 seconds. When you consider, I don't know, tuning fork A or B, I don't know. Tuning fork, let's say. When you consider tuning fork A in the displacement time graph, within 0.25 seconds only, 8 cycles happening. When you consider 1 second, number of cycles happening is the frequency. I mark it as F1. I mark it as F1. Right? Then you can find F1 frequency. Within 1 second, number of cycles is frequency F1. F1 is how much then? F1 is when you simplify F1, you will get your F1 as how much? You will get your F1 as just divide 0.25 over 1 must be equal to 8 over F1. So when you do the simplification, F1 going to be how much? F1 going to be equal to how much? 32. How much? Okay, we'll do like this. 0.25 over 1 must be equal to 8 over F1. Substitute F1. When we substitute F1, F1 going to be how much? 8 over 0.25. 32 hertz. Likewise, look at the displacement time graph of B. Second one's displacement time graph. Second one's displacement time graph refer. In there, In there, how many wave cycles are there? Within 0.25 seconds, when you check the wave cycles, full wave cycles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hands up, who agree? 11 hands up. 11 hands up. 11 cycles hands up. 11 cycles. You also check, sometimes I can do a mistake. 11 cycles. 11 cycles happening, sorry, within 0.25 seconds, 11 cycles happens. What is frequency? Frequency means within 1 second, how many cycles happening? The frequency. Frequency F2. Frequency F2, when you substitute F2, your F2 going to be 11 over 0.25 means 44 hertz. I taught you that. Now we found tuning fork A's frequency, for an example, 32 hertz. Tuning fork B's frequency is 44 hertz. What is beat frequency? How to find beat frequency? When you take the difference of frequencies of tuning fork A and B. When you take the difference of tuning forks of A and B, that is the beat frequency. Then beat frequencies, we all know that. Larger one is F2, F2 minus F1. 44 minus 32 is how much? 44 minus 32. 34, 44, 12 hertz. Nice question. Learn. It's completely alright, you don't know the stories. You are going to stay with me and you are going to like you learn theory. Now, yeah, you are not, okay, I can't advise. Okay, now theory class I will advise. No time. I can read some stories, but no time. I advise no time. 13 done. 14. 14 I had done similar stories. 14. 14, someone help me. 14 story. Question number 13, the answer is question number 13, the answer is 12. 12 means fourth one. 12 means fourth one. Question number 14. In 14, frequency of the tuning fork is noted to be 512 hertz. When a vibrator vibrates the head at a frequency of 514 hertz, the beat frequency is 2 hertz. When the vibrator vibrates at a frequency of 510, the beat frequency is 6 hertz. It should be harmonic frequency. Beat frequency is 6 hertz. The two tuning fork frequencies. Now, in the beginning, they are telling me frequency of the tuning fork is noted to be 512. That's not correct. They are telling that's a tuning fork. Its frequency may be 512 hertz, but not sure. Maybe right or maybe wrong. That's why they are asking us to find the frequency of that tuning fork. So please don't consider that frequency is exact frequency is 512. Don't consider like that. The tuning fork's frequency we don't know. Then we are vibrating the tuning fork with vibrator. That vibrator frequency is 514 hertz. Okay, that's a vibrator, right? That's a vibrator. Look here. Look here. Look here. So there's a vibrator. So frequency increases in this vertical axis, upward direction. If I mark the vibrator, in the beginning they told that vibrator frequency is how much? In the beginning, vibrator vibrates at a frequency of 540. Vibrator's frequency is 514 hertz. Vibrator frequency. Now, we are vibrating the vibrator with whom? With the tuning fork. The tuning fork and vibrator both are vibrating. Vibrator vibrates under 514 hertz. Tuning fork's frequency we don't know, but they have given the beat frequency. When you vibrate with the tuning fork, beat frequency is 2 hertz. Then you can predict that maybe the frequency of the tuning fork can be 516 hertz. Maybe it can be 512 hertz. Tuning fork frequency can be tuning fork 516 hertz. If not 512 hertz. Why they have given beat frequencies 2? Beat frequency 2. So still we don't know whether it's 516 no, whether 512 we don't know. That's what we are going to decide. Okay. Maybe tuning fork frequency can be 516. If not, tuning fork frequency can be 512. We can't confirm it yet. Again, they are telling when the vibrator vibrates at a frequency of 510, beat frequency 6Hz. And the next story again. Now what have they done? They have changed the vibrator frequency. Now vibrator frequency is now same tuning fork, different vibrator. Now vibrator's frequency is how much? 510 Hz. This time when you vibrate this vibrator with the same before tuning fork, beat frequency 6. Then one can tell, so then tuning fork's frequency can be 516. If not, tuning fork frequency can be 504, right? Both the scenarios you use the same tuning fork, but actually you have changed the vibrator. Same tuning fork used to both the cases. In the first case, vibrator frequency 540, then tuning fork's frequency can be 516 or 512. Second scenario is the same tuning fork, vibrator frequency 510, tuning fork frequency 516, 504, which satisfy both the scenarios. 516, right? Tuning fork frequency must be 516. Tuning fork frequency must be 516. Nice story. I have done these questions, but exposing to different stories. Then answer is 516. Answer is fourth one. Question number 14. Answer is fourth one. How many discussed so far? So tell me how many questions we discussed so far? How many we discussed? Reply. Have we finished 20 at least? How many finished? How many we finished so far? So far, how many finished? Can someone tell me? You ain't done. You ain't done. Last 5 to go. Is it 20? Then what we have done? Okay, 10 done. 10. 9 and 10. Okay, we got 9 and 10. Question number 9, question number 10. Question number 9, question number 10. Question number 9. Finish 20 or 19? Someone reply. 20 or 19? Reply. Reply, guys. How many we discussed so far? Everyone reply. How many finished discussing? How many finished? 19. 19. Oh, 19. Eh? Why, man? Why it's not finishing? Why it's not finishing? Six to go. Last 16, 23. 2.5 an hour. 9. Okay. Question number 9. Maximum and minimum value of resultant of two forces P and Q acting on a point is 23 and 7 Newton. Find the magnitude of the resultant when P and Q acts perpendicular to each other. This story I can explain nicely. Just consider there are two vectors. This story you should know this story. Just consider there are two vectors like this. Vector P, for example, this vector is vector Q. Let's see the angle between these two vectors is theta. So remember, just think magnitude of vector P and magnitude of vector Q doesn't change. They are constant. When angle changes, you know, the directions of vector PQ may change, right? When the angle changes, the direction of vector P and Q change. But magnitude of vector P and magnitude of vector Q doesn't change. So you know that based on the theta angle, the resultant vector changes. Based on the theta angle, resultant vector's magnitude and direction changes. That's obviously. Resultant vectors, magnitude and direction changes. Okay. Result vectors, magnitude and direction changes. That story remember. Okay. Short on important points, huh? Important points. If the vector P and Q magnitude doesn't change, based on the angle, result vectors magnitude and direction changes. So in this scenario, what is the minimum resultant magnitude? In this scenario, what is the maximum? What is the maximum resultant value? Okay. The minimum and maximum. The minimum and maximum. So we will get the minimum resultants magnitude what scenario? We will get the maximum result in what scenario? Okay. So see, when the angle between this story is important, I roughly tell. If I have time in upcoming days, I will tell you properly. When theta is 0, what will happen? Important points, short note points. In vector, short note point, short note point. When theta is 0, remember, you are vector P and vector Q in the same direction. When the theta is 0, vector P and vector Q in the same direction. Right? Then remember, result is maximum. Vector P and vector Q both in the same direction. Then the result is maximum. Result is maximum. When both the vectors in the same direction. Now, no matter when the theta is varies from 0 to 360, that is theta is varies from 0 to 360. Remember, when theta is 0, both vectors act in the same direction. Then the result is maximum. Result is maximum. The magnitude of result maximum can be given by magnitude of vector P, I say P, magnitude of vector Q, I say Q, P plus Q. Short note. Short note, huh? Short note. Short note stories. Next story. Next story. Remember, when theta is 180. When theta is 180, remember, vector P and vector Q opposite, which gives the minimum resultant magnitude. When you have vector P and vector Q, angle is 180. This angle is 180. Remember, resultant is minimum. Magnitude resultant is minimum. Story I can explain by using the angle. I can prove that, but not to prove it today. Okay. Remember, minimum resultant will be equal to magnitude of vector P minus magnitude of vector Q. The story learn by heart. Short note point. Short note point. Every question learn. I know maybe you don't know the stories. That's why in the classes I'm past sessions I'm discussing these stories. Right. Now I think it's straightforward question. They have given maximum resultant value and minimum resultant value. Maximum value is 23. Minimum resultant is 7. Then that means P plus Q, P minus Q. So you can tell that that means P plus Q is how much? P plus Q is 23. P minus Q is, for example, 7. Simultaneous equations. Then simplify. Simplify simultaneous equations. I'm quickly simplifying. When I simplify, my P going to be, we simplify it, my P going to be 15. Q going to be how much? Q going to be 8. Am I correct? Right, if you simplify it, I don't simplify it, is the answer. Right, but they're asking when these two vector P and Q acting perpendicular directions. P is 50 Newton, Q is 8 Newton. They are asking the magnitude of resultant vector. They are asking the resultant vector. So we learned in vectors, when there are two vectors perpendicular to each other. When there are two vectors perpendicular to each other, the resultant vector equation we know. Resultant vector equation is P square plus Q square whole root. This story we learned when there are two vectors perpendicular to each other, resultant vector magnitude is P square plus Q square whole root. You should remember this story. Then simplification. Here 15 squared plus 8 squared Whole root means 225 plus 64. 225 plus 64, how much? 225 plus 64 means 285, 89. 289 means how much? 17 into 17. 17 into 17 means 49, 11, 7, 1. Yeah. When subject, you are going to be how much? You are going to be 70 Newton. Hands up. The story is clear, hands up. This story is clear, hands up. This story is clear, hands up. This story is clear, hands up. Yeah, quickly I'm doing. Since we want to finish soon. Already 10:30. Normally it takes 3 hours. I told you 25 MCQs, we need 3 hours. Right question answer is 7 Newton. What is the answer? Nice question, huh? I think you can revise a lot. Short note points. Short note point. You can revise a lot. Just refer it. Read these questions again. Then you get the 100% benefit of doing this paper class. Coming for this paper class. Question number 9. Then the answer is 17. Second one. Second one. Last 5 to go. Last 5 to go. 10 is there to discuss. 10 is there. Horizontal range. Okay. Right. Then I discussed other than, okay, 10. An object of mass 6 kg is in equilibrium on a smooth horizontal surface as 3 coplanar horizontal forces 6, 9, 12. An object of mass 6 kg is in equilibrium on a smooth horizontal surface as 3 coplanar horizontal forces 6 Newton, 9 Newton, 12 Newton acting on the object. If one or two of the above forces are removed, the object will move at an acceleration of 2 ms minus 2. The forces to be removed, these are. Nice question. Simple question only, but you can easily make wrong. The simple question only, but you can easily wrong. Question number 10. Question number 10. You can do mistakes. You will do mistakes. Okay. Why, man? Yo. Right. Okay. Question number 10. Look at the story. Last one. There's an object. There are 3 coplanar forces at horizontal. Its mass is 6 kilograms. How many forces horizontal? 3 horizontal forces acting on this object. 3 horizontal forces. 3. One is 6, 9, 12. They are telling smooth horizontal force surface. 3 coplanar horizontal forces. 3 coplanar horizontal forces. If give me 1 second. 6 kilogram is in equilibrium, smooth horizontal surface has 3 coplanar horizontal forces. 6, 9, 12. Our mass can be in equilibrium. 9 and 6 means 15. Acting on the object. If 1 or 2 of the forces are removed, object will move at an acceleration of 2 ms minus 2. Object of mass 6 kg is in equilibrium. 3 coplanar horizontal force. I think it can't be horizontal. It can't be horizontal, okay? There is a small mistake. It should be 3 coplanar forces. It can't be horizontal. If it is horizontal, under 6 Newton, 9 Newton, 12 Newton, object can't be under equilibrium. Therefore, they should tell an object of mass 6 kg is in equilibrium on a smooth horizontal surface as 3 coplanar forces. not horizontal forces, 3 co-operative forces. Okay, then may be correct. Then may be correct. Okay, there are 3 forces. As per my understanding, I think that if this is 6 Newton, inclined forces, if this is 6 Newton something, this might be 9 Newton. This can be maybe 12. So it seemed like this type of diagram. But it can be this side can be 12 and this can be to 6. If not, this side can be 6 and likewise. There are some stories, okay, right? But currently they are telling this object is under equilibrium. This object is under see, currently object is under equilibrium due to these 3 forces, right? So then that means the resultant of 6 Newton and 9 Newton must be equal to 12, right? If this object is under equilibrium, when you find the resultant of these two, am I correct? When you find the resultant of these two, that must be equal to 12, opposite 12. When you find the resultant of 6 Newton and 9 Newton, that must be equal and opposite to 12 Newton. Then only this side 12, this side 12 cancel out. System, object will be at equilibrium. Am I correct? Now they are telling under these 3 inclined forces, this object is under equilibrium. That means resultant force must be 0. That means resultant of these two must be equal to 12, opposite 12. The resultant of these two must be this direction 12. Okay, that's the idea. If one or two of above forces are removed, the object will move at an acceleration of 2 ms minus 2. Right? Now, we don't know what force they are going to remove. They told that when you remove one force out of the 3 forces, you can remove one of them. You can remove 12 Newton. If not, you can remove 9 Newton. If not, you can remove 6 Newton. If not, you can remove 2 forces out of 3. You can remove 12 and 9. You can remove 6 and 9. You can remove 6 and 12. I don't know what you are removing. But they are telling once you remove 1 or 2 forces, acceleration is always 2 ms minus 2. For this object, let's say it can move horizontally. When you apply F equals ma, for the object, mass is 6 kilogram, right? You don't know what force you are removing. You don't know you're removing 1 or 2 forces. But once you remove 1 or maybe 2 forces, object always obtain acceleration 2 ms minus 2. Mass 6 kilogram, acceleration 2 means we can find the resultant force acting on the object when you remove 1 or 2 forces. Before removing any force, result is 0. Once you remove 1 or 2 forces, result becomes 12 Newton. Then tell me, in order to have a resultant 12 Newton, how you can remove, what the forces you can remove? In order to have a resultant 12 Newton, what force you can remove? One can tell, sir, if I remove, now you told me to remove 2 forces, sir. You told that I can remove up to 2 forces. Out of these 3 forces, I can remove up to 2 forces. Then you are telling once I remove 1 or 2 forces, resultant must be 12 Newton. So therefore, I am removing 6 and 9, sir. If I remove 6 Newton and 9 Newton, sir, then in my system, there is only 12 Newton. That is resultant. You wanted to maintain a 12 Newton force, resultant force, after I remove 6 and 9. Then if I remove 6 and after I remove the forces 1 or 2, you want to maintain resultant 12. If I remove 6 Newton and 9 Newton, there is only 12 Newton force acting on the 6 kilogram mass, therefore result is 12. Then what can someone tell, sir? That person is removed 6 and 6. That person removed 6 Newton and 9 Newton, then the result almost 12 Newton. That's also correct. But sir, I am removing only 12 Newton, sir. If I remove this 12 Newton, these two remain. 6 and 9 is there. We know 6 and 9's resultant is 12 earlier. Then I can remove only 12. So one can remove 6 and 9. If not, one can remove 12. Both the cases you will get resultant 12. 12 only, 6 and 9 only, A and C. Answer is 4. Hands up, that's a nice question. If you understood F equals ME, it's a nice question. Hands It's clear answer. Answer is clear answer. It's clear answer. Genuinely answer. It's clear answer. Genuinely it's clear answer. Genuinely very clear answer. Genuinely it's clear. It's very clear. Can explain more, but no time. Ni. Won't finish. If we keep on tomorrow other day, it's a problem. Ni. It's a problem. That's a problem. A and C answer is for nice question. Very nice question. Huh? Very nice question. Some questions simple but very nice. Very nice. How many? How many to go? 10 discussed, 11 done, 12 done, 13 done, 14 discussed, 15, 16, 17. 17 story. 17. 17. 17. Look here, 17. 17 story. Very simple. Equilibrium. Again, equilibrium. Equilibrium. Many questions, equilibrium related questions. Equilibrium. Story they are telling. Story they are telling. Cube of wood of mass 0.5 kilogram and density 800 kilograms per meter cube. Fastened to a free end of vertical spring of spring constant 50 Newton per meter fixed at the bottom as shown in the figure. Now the entire system is completely submerged in water, elongation, extension, change in length of the spring at equilibrium. Simple. So what you want to do is simply, since this object they have given, it's a wooden cube. Just mark this, they mention wooden cube is under equilibrium. Mark all the forces acting on this wooden cube. Weight of the wooden cube downwards, mg. Upthrust of the wooden cube is upward, u. I mean this red color paint. Weight is mg. Downwards, upthrust u upwards. Tension acting on the wooden cube due to the spring. That is also downwards. Tension downwards. Capital T. U upwards. Mg and T downwards. When you consider the equilibrium of the wooden cube, you can tell that equilibrium upward forces must be equal to downward forces. Including this, how many finished? Someone tell me. Upward force must be equal to downward forces. That means U must be equal to T plus Mg. T plus Mg. Upthrust, we learned U equals V rho G. Upthrust means we learned that. Upthrust means we all know, sir. Just now today also we learned V rho G submerged volume density of water, G gravitational acceleration. And we all know mass over volume equals density, this idea. Sir, upthrust means submerged volume. Submerged volume of the wooden cube means, if I substitute volume in this equation, volume means mass over density, sir. Volume means mass or density. Submerged volume will be mass over density. Mass is 0.5 over density of the wooden cube is 800 into I know volume. Volume means mass over density. Okay, this is the volume. Then rho means density of the surrounding liquid is 1000 water, and the gravitational acceleration is tensor. Must be equal to. So tension acting on the wooden cube means we know the spring has stretched, spring has elongated. Today only we learned that to find the tension acting on a spring, F equals Kx equation. F equals Kx equation we learned this. Today only we learned F equals Kx equation, sir. F equals Kx equation. We learned this story. Same thing repeating, sir. Tension means I want K, they have given 50. K, they have given 50. I want to find X. Want to find X. Sir, mass of the wooden cube is they have given it's 0.5 kilograms. 0.5 kilogram mass is 0.5 kilograms, sir. 0.5 into 10 G is 10. Sir, want to find X? Simple. So if I substitute X, I get the answer, sir. Subject X 0, 0, 0, 0. We are getting here 0.5 into 100 is how much? Somehow 0.5 into 100 means 50. 50 over 8 means how much? 50 over 8 means 25 over 4. 25 over 4 means how much? 25 over 4 means 25 over 4 means 6.25 must be equal to 50 simple x plus 5 ni. plus 5 plus 5. So when you simplify further, simple is going to be 1.25 over 50. Simple is going to be 6.25 minus 5 means 1.25. 1.25 over 50 means so 1.25 over 50 meters, right? If you want to convert to centimeters, how do you convert meters centimeters? How do you convert meters centimeters? We multiply by 100. If you want to convert meters to centimeters, we are multiplying by hundreds. Am I correct? We are multiplying by hundreds. In that case, if we multiply by hundreds, here it's 1, here it's 2. Sir. So answer going to be 2.5 centimeter 6. Including this, how many finished? How many finished including this one? How many finished? Including this, how many finished? 2.5 is the answer. Guys, tell me how many finished so far. Quickly, guys, tell me how many finished so far. How many finished so far? How many finished? How many finished? How many finished? 22. 22. 3 to go, ne? 3 to go. 3 to go. We can't reduce the questions. 25 is the correct amount. Okay. This question answer is fourth one is the answer. 17 fourth one is the answer. 7 fourth one is the answer. Someone send me this marking scheme to me. Someone send me the marking scheme to me. 1 to 25, what are the answers I marked? Then 17 done, 16 discussed, 17 done, 18 done, 19, 21, and 25. Right, last three to go. Last three, 19. Two waves of wavelength 2 meters and 2.02 meter are traveling at same speed and superimposing produce 2 beats per second. 2 beats per second. What is the speed of the wave? I have done this question, similar question in our theory class. In our theory class. Question number 19. Nice paper. This paper is nice paper. Well balanced paper. Now we know V equals F lambda equation. We know two waves traveling, wavelength different, right? But you know, producing beats means we know frequency different. Those two waves producing beats means frequency different. Wavelength different, frequency different. Remember, both the waves have same velocity. They clearly mention two waves having different wavelength. If they are producing beats means their frequency also different. Short note points. Then the velocity is same for both of them. Velocity is same for both of them, right? So then we can tell that subject the frequency going to be equal to what? Velocity over wavelength. Both the waves velocity is same. That means larger the wavelength. We all know both the waves velocity is same. Larger the wave having larger wavelength have smaller frequency. Then tell me, out of those two waves, wavelength 2 meter, wavelength 2.02 meter, which one has the larger frequency? Larger wavelength have smaller frequency. Larger wavelength is 2.02. 2.02 meter have smaller frequency. 2 meter have larger frequency. So if I find frequency of the first wave, F1, that is V over wavelength is 2 meters. Frequency second wave is V over wavelength is 2.02. So they mentioned beat frequency, the difference of now this wave frequency is F1, and the next two frequencies F2. The difference of the frequencies of the wave is beat frequency. They mentioned beat frequency is how much? Beat frequency is 2. F1 is larger, F2 is smaller. F1 minus F2 is 2. Substitute. F1 is you want to find V. Substitute V over 2 minus V over 2 minus V over 2.02 must be equal to. Nice question. Last two almost 11. So when you substitute V, your V going to be 2 into 2.02. 2.02 minus 2 means 2.02 minus 2 means 0.02 must be equal to 2. That means here, when you simplify it, 0.01, somehow you are getting your V as how much? Somehow you are getting a V as how much? 404 ms minus 1. If I'm wrong, tell me. 404 ms minus 1. So you just do the simplification. 404 ms minus 1. Your V is 404. We simplify it, yes, correct? 2.02 minus 2 means 0.02. 0.02 here, there 0.01. Here 2, 202 means here 101. Correct? Yeah, 4 and 4. Answer is second one. If I'm wrong, tell me. Answer second one. Second one is the answer. Last two. Last two story finished. Last two. Last two. 23 done. 21. 21. Next story 21. 21. Right. 21. In 21, what are they asking? 21 is easy. Seem like very difficult question, but very easy. 21. The figure below shows four objects A, B, C, D located initially on the displacement line. Displacement line. Four objects start their motion with given speeds and move with the same uniform speed. Both four objects move under constant speeds. Right? Now see, object A is going right side under constant speed, 2 ms minus 1. Object B moves under constant velocity right side, 8 ms minus 1. Object C moves under constant velocity, 4 ms minus 1 left side. Object D moves under right side, constant velocity, 4 ms minus 1. Very simple. Which of the following correctly shows the rough diagram of the displacement time graph for the motion of forecast? We know that if all of them, if we know if an object moves under constant velocity, look here in displacement time graph, I taught you the gradient under displacement time graph, the gradient under displacement time graph represents what? Y-axis represents displacement, gradient of the graph, gradient under displacement time graph represents velocity. Short note point, gradient under displacement time graph represents velocity. Short note point. Short note point. Short note point. Y-axis represents displacement. So you can tell me easily, see, larger velocity means larger gradient, larger acute angle. See, larger, now right side direction. Look here, normally we consider, now I can explain. Right, remember the story. Story normally, we consider right side direction as positive velocities. That means gradient positive. Now because gradient is velocity. Gradient is velocity. Remember acute, okay, short note point. I explain stories in the motion graph story. If you want to join, you can come to 27 theory classes. We are starting motion graphs. Last week we started. You can learn stories properly. Remember, in a graph, now this displacement time graph, gradient is velocity. If a graph is acute angle, remember gradient is positive. Then remember gradient of ST graph is velocity, positive velocity. That means right side direction velocity. Short note, I don't explain why. If the angle is obtuse angle, remember negative gradient. That means remember negative velocity, left side velocity. Short note story. This is a short note. Short note idea. Short note idea. Short note idea. If you want to learn this graph properly, join for the 27th class. You have the access. 26 theory people have free access. I have given 26 theory people free access for 27 classes. Even you miss unit 2 mechanics, you can learn everything from the beginning. Now tell me. Now see right side direction. When you consider ABCD, right side direction velocities are what? 2 A's velocity right side 2. And B's velocity right side 8. And D's velocity right side 4. Then when you consider A, B, and D, their graphs must be acute angle graphs. Acute angle graph means this type of graphs. Acute angle graph means acute angle graph like this, acute angle graphs. The left side velocity means negative gradient obtuse angle graphs. Obtuse angle graph means it's type of graph. Then you know a point C has a left side 4 ms minus 1 obtuse graph, right? And also you know larger the acute angle, large the gradient. Remember, larger the short note point, large the acute angle, large the gradient, larger the gradient, therefore larger the velocity. Remember, smaller the acute angle, smaller the gradient, smaller the velocity. Short note point, short note point. Obtuse angle. Large the obtuse angle, smaller the negative gradient, smaller the velocity, negative velocity. Smaller the obtuse angle, negative gradient larger, larger negative velocity. Short note point, I don't explain why. Tell me what is the answer? What is the answer? So when you compare right side acute angle, right side A, B, D velocities, right side, right? Then A should start at displacement of object is 0 in your displacement time graph. In your displacement time graph, A's displacement is 0 meter, 0. The graph A should be start from 0. Then right side direction means acute angle. It's a 2. This is 2. This is A. When you consider B, B's velocity is 8 ms per right side. 8 ms per second larger than A. Velocity of A is how much? It's 2. Velocity of B is right side 8. The larger the gradient, larger the acute angle. But B's displacement is how much? 10 meters. Larger acute angle. This is B. When you consider D is at a negative displacement, minus 10. Its velocity is greater than A, less than B. Something like this. Tell me what is the right answer. Please tell me someone quickly. D is then C is left side direction. Plus 30 something. Left side direction, something like this. Tell me what is the right answer. Tell me right answer. Tell me no time. I have no time to listen. 11 o'clock. Right answer. Tell me what is the right answer. What is the right answer? Tell me quickly. What is the right answer? Someone tell me, man, right answer. I have given all these ideas. Right answer is how much? Right answer is how much? What is the right answer? Guys, what is the right answer? No one is telling me. Ayyo. Anyone? Can someone is the right answer? A is 2, then D, then second one is wrong. First one is wrong. Third one is also wrong. Third one is wrong. When talking about 4 and 5, what the right answer? What do you think? Give some replies, guys. Why not responding, everyone? Give me some answers. Should give me answers. Reply, everyone. What do you think is the answer? Should reply. If I ask you guys to reply, should reply. Then it's very difficult, right? Need your support, What you feel, you tell the answer. 4 and 5 look similar, but it's an answer. The answer is A okay, D okay, B okay. Look at the C. When look at C, answer is we know C. When you compare C and D, have 4. Look here. Answer is 5. You know why? So when you consider in this ST graph, D velocity is 4. D's velocity is 4. When you consider C's velocity is 4. So they are gradients almost same. So therefore, their gradient must be same, right? Their slopes must be same. So when these two graphs meet together, it should create a kind of what do you call two-side equal triangle? What do you call? Should create some kind of two-side equal triangle. Answer is 5. Answer is 5. If you don't understand, ask that story later. I will tell you next day discussion. I will tell you. Today, want to finish the last question. Last question, 25. 25, very simple. Rock is projected from a horizontal surface at an angle 45 degree from the horizontal. Correct diagram showing the horizontal displacement, vertical displacement, horizontal displacement, vertical distance. See the way that they can trick us. Showing the horizontal displacement, vertical distance. The correct diagram showing the horizontal displacement, vertical distance. Right. Now we know that when you consider projectile motion, the last question for the day. Last question for the day. Last question for the day. Question number 25. Right, in projectile motion, I taught you one story, important point. Throughout the projectile motion, first story is horizontal velocity component is constant. Short note point. In a projectile motion, any point horizontal velocity component is constant. Right? So then we can, when you consider equivalent horizontal motion, when you consider equivalent horizontal motion, you can tell that it's a constant velocity motion. It's a constant velocity motion. When you consider equivalent horizontal motion, it's a constant velocity motion. Then they're asking horizontal displacement time graph. If when you consider equivalent horizontal motion, if it's a constant velocity motion, displacement time graph, constant velocity means straight line. Okay? Straight line. Okay. Displacement time graph. Constant velocity means what? Constant velocity means constant gradient. Constant gradient means constant acute angle. In the stories. Therefore, constant acute angle to the graph, straight line. But next story, they are asking the vertical distance. When you consider equivalent vertical motion, that is equivalent to a projectile motion. That is equal to vertical motion under gravity. When you consider equivalent vertical motion, that is a vertical motion under gravity question. Going upward at the maximum height, velocity becomes 0, again going downwards. Right? Right? So if you draw the distance time graph, not displacement, distance time graph, what happens when the object starts from the ground and as the object goes upward, velocity is decreasing. Sorry, speed is decreasing. Now we want to draw the distance time graph, then speed is decreasing. Speed is a scalar. Speed is a scalar. Upward direction, speed is decreasing. Speed decreasing means we know that distance time graph, gradient is what? Distance time graph, gradient is speed. I just told this. Gradient in distance time graph is speed. So upward in the beginning, upward direction, speed is decreasing. Speed decreasing, that means gradient decreasing. That means acute angle decreasing. The story. Acute angle decreasing. Acute angle decreasing. At the maximum height, speed is 0. At the maximum height, speed is 0. Equivalent vertical motion. Equivalent vertical motion. At the maximum speed is 0. The projectile motion at the maximum height, vertical velocity component is 0, but still at the maximum height there is a horizontal velocity component. Therefore, if a statement they are asking at the maximum height in projectile motion velocity is 0 means wrong. Vertical velocity is 0, but still it has a horizontal velocity component. Right? When the object again coming down, what's happened to the velocity? When the object is again coming down, what happened to the speed? Speed is again increasing. Speed increasing means positive gradient increasing, right? That means acute angle increasing. Any graph for this? Third one. Third one is the answer. I think last two questions I went with a hurry. If you want to discuss it again in next paper class, tell me. I will discuss next paper class properly last two. But anyways, I hope everything is crystal clear. Everything is crystal clear, hands up, everything. 11.5. Everything is crystal clear. Please respond. I need your response, okay? If I ask something, you should respond. Hands up, crystal clear, hands up. Crystal clear, hands up. Crystal clear, hands up. Right, very effective session. I think it's very effective. Last two questions, last two, three questions, I went so quick because 11.5. Today I want to do something else only. That's why I'm doing quickly. Tomorrow next day, if you want to redo these questions again, tell me. I will redo it again once again if you request. So homework, redo the questions again. It's a must. Like how you write a paper, like how you join for a discussion. Redoing this question is a must. But the homework is what you learned in this session, short note every point nicely. Target paper to short note. Take a separate book. Take a separate book. Target paper class, short notebook. What you learned nicely, send me as a homework before 1 a.m. It's a homework, but even you didn't do, I'm not going to I'm not going to angry with you. I don't do anything. I will support still the way like how I support, but you should do, it's a must. Right. Class is finished. We'll